In this video, we're going to be talking about covalent Lewis dot structures. First, the steps are given. Start with the correct formula, which is carbon dioxide, CO2. And then, just like the previous video, ionic Lewis structures, and elemental Lewis, we're going to draw the dots and how many are there. So there's 1 carbon and 2 oxygen, with oxygen, if we look on the periodic table, has 6 valence electrons, and carbon with 4, if I can find it right here, and it's already given. We're going to draw lines connecting it, the lonely electrons, and we're going to redraw the structure, and this is what it looks like. So how do we get there? That's the main question here. So we're going to first be going back to this step. The dots on the anion shouldn't be lonely, so it should be shared. So the dots are going to go to the oxygen as a step. So this one's going to go here, making sure that the oxygen maintains an octet. Not all of them does in the end. So if we look at the structure, the lines, in this example, this is a double bond, and this is also a double bond, and the lines represent 2 valence electrons. So if we count the valence electrons for carbon that are shared, it's 1, 2, 3, 4, 5, 6, 7, 8. And then we count for oxygen, we have 1, 2 as a lone pair, 3, 4, 5, 6, 7, 8, and it's the same thing for here. And then we just count to make sure that it's right. And you know for a fact that it's right because they all have 8 now. So when they all have 8, it's a perfect octet. Everyone's happy. So the leftmost element will be the central atom, and the central atom will just be in the middle, in between the other atoms. And back to what I said, each line represents the 2 electrons being shared. So we're going to do 2 different examples now, H2O and CH4.
For H2O, the first thing that we need to do is switch over the camera. Okay, so for H, we have 2, and then for the O, which is oxygen, we have 1. The H represents hydrogen, which only has 1 on each, and oxygen has 6. 2, 3, 4, 5, 6. Okay, so then we have to give each one to share, and then we have to rewrite it to where it looks nice. So we have H going to an O, going to an H. Okay, and then we have our lone pairs, which you can see here and here, are just on the top and the bottom. So now that we have our covalent Lewis dot structure, we can talk about VSEPR, which is the shape it makes when it's in 3D. So if we go over here, we can see that we have 2 bars, and that we also have 2 lone pairs. So if we go up here, for the numbers around the central atom, we would have 2, which is over here. Oh wait, what has 2? Okay, so yeah, we have 2 lone pairs and 2 atoms, which puts this at a bent. Okay? Now, for CH4, we have 1 carbon and 4 hydrogen. The hydrogen all have 1. while the carbon has 4. If we then give and connect, we can make a very big mess of our lines because this is not a pretty picture. So since we want it to be a pretty picture, we're going to change it and rearrange so that the lines do not cross. Now, as you can see, on this one, we did not have any lone pairs. So when we go to the VSEPR, we are looking for 0 lone pairs and 4 connecting points. This makes this one a tetrahedral.
And then also one more thing is that you can tell that hydrogen, why does hydrogen only have 2 valence electrons? Well, hydrogen is a special case where hydrogen only wants 2 valence electrons. So, but if we count for O, it's still happy because it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And if we look at carbon, it also has 8. So 1, 2, 3, 4, 5, 6, 7, 8.